My friends, thanks for tuning. So today we are at lesson 14 of the infrastructure security course, and let's have a look at the syllabus. We are almost at the end of chapter first, and we are going to discuss zero trust access, all portion of SASE design, and a lot of marketing work around in terms when we present stuff. Let me remind you that on the Security Boutique channel, you are having a playlist, Infrastructure Security Consultant free course, and you'll have all lessons listed here. Okay? So feel free to pause me at any time. So SASE is supposed to be the convergence of all layers and let the infrastructure to be tunneled through a layer that does have visibility of all interaction on the client side and also in terms of CDN facing all other service in terms of access. So SASE is the evolution of a CASB strategy. CASB was a cloud access broker, and SASE is a bit more wide concept that is going to include every type of service dependency in the access of the resources. So SASE is in summary where everybody connect to, and the sum up of all service they need from the cloud, the proxy services, link, connectivity. SASE integrate also with sd-wan service and is supposed to become just a big layer where the security team can have visibility of everything and where it is possible to enforce control and policy, have DLP controls, and so it's the entry point. But there are some issues that are design infrastructure wise quite important. Cloud service provider don't want nobody in the middle. And so you find out that, for example, if you're having an access to a Google service, you have TLS 1.3 straight and no man in the middle is possible. So even your service is not allowed to be there. The design solution for that is generally to keep those kind of access offline. So client goes directly and the API of a service notify to your layer that somebody got access. That make not a real time kind of logging. It does allow some problem if there is an escalation of privilege or a change of credential, because you always consider in these services that one user, one credential. It's true, but if it's an attacker, it can change. It can have more than one. And so whatever is thought as original normal behavior could be different then. So you need always correlation in your layer to understand all these kind of potential pattern. User behavioral analysis is a bit underestimated in terms of how helpful can be to slim down the number of cases to really connect the dots. So if you are working on a strategy, on a SASE strategy, work on having a good behavioral analysis that correlate identity. So we are going to talk about zero trust, conditional access, but zero trust access suppose that you recognize not just the user but also the device that access to the layer. The problem there is that you're supposed to be on a device that get orchestrated and somehow you have visibility of fingerprinting of that. Whatever system of fingerprinting can be bypassed at the moment that you know the structure of the fingerprinting. And it's quite common on web application. For example, you identify browser or a sum up of parameter in the HTTP request, and you fingerprint that. Session is actually the best way to fingerprint somebody. But you need to pay attention that session can be actually hijacked. So potentially, if you hijack a session, you bypass all your authentication. Because if you have a valid session, you don't have any way to force your and hijack and try to compromise an attack, an authentication and authorization stages. That is quite important for you to understand on how a layer 7, that portion of a session is extremely important. When you are talking about SASE, we talk about conditional access, where you actually fingerprint and you understand how a device is compliant or not compliant. Check it out this post whenever you have time, and it will go through how we bypass the conditional access. And it's an interesting reading because you see that most of the promise are anyway going to disappear. So you need to think when you are doing a security architecture design on something, you need to think how get bypassed and get attacked. So if you compromise the compliance of a device and you also steal the session, what is left of your zero trust access? That is a question that you should answer. Another point is TLS 1.3 is obviously something that you need to look at. And so the encryption of a SNAI in the packet is called ESNAI. And suppose that you have a public key into the DNS record. Now, when you talk on ESNAI, it looks like a geeky kind of conversation, but it's not. Because if you have a business that scale around, you see how this conversation of ESNAI is important into proxy and visibility. So much that get blocked in China. So this one is a difficult lesson because I'm not trying to point the finger to any kind of vendor at all. But I take an example. You go into a documentation about a support for TLS 1.3, and in the documentation is written, in the transparency proxy modes use the SNAI in the client law that indicate the domain to the product. Now, it's not this one, everybody does. So the actual support on TLS 1.3 suppose that there is no key into the DNS and there is no usage of ESNAI. So if you make a balance into all these equations, you see we try to design something secure, but we need to make it less secure to be capable to see and make it secure. It's not going in a good, it's not a conversation that is flowing like it should. If you use TLS 1.3 and you don't use a ESNAI, what is the benefit? Because actually the traffic can be seen in terms of destination and everything. And so do you want to find a situation where you are having a support to a certain type of TLS, but with a downgrade of the full potential of a TLS? And as I said, I took a documentation. I can check whatever vendor you want. There are tons, and it's just a technical conversation. It's not, as I said, nothing pointing the finger to the vendor. It's just a problem of the market. If you add the complexity in terms of IPS, IDS, everything need to interrupt, you see that actually the only solution that you are having is probably at CDN. And so working into a CDN VIP that is front-facing and is actually having the key with SNI is the right way to go. But you can't offload and interrupt connectivity to all management interfaces. And so you need to think that you have around 15 minutes of delay on seeing the traffic if you're using a CASB offline. So all this stuff is not actually advertised nowhere. And so you need to use your own thinking to understand the complex picture. And I don't see many material out there highlighting these problems. So you need to think on how is your design and is it really covering everything? Another conversation is DHCP. At the time that your endpoint is connecting to a cloud service, suppose that you got already network connectivity and you got already a DHCP telling you something, including the DNS. So you can use an always-on VPN pointing to something, but there is always a trust level where somebody else already route you somewhere. So think about it. In your design, you need to be 100% sure that you trust even the first package. And there are situations where this problem can't always be fixed. So you need to understand in your zero trust design what you actually trust. Sounds like I'm playing with the words, but it's a valid point because there is always a trust. Like in when you are booting your laptop, you do trust a layer that is your BIOS or whatever. So considering your ZTA not just the marketing, but how the pieces work together and which trust boundaries you are having and which you are willing to accept. Each product works differently, but they tend to have all the same limitation and problem. And so whatever solution marketing want to show you, you need to approach on trusted boundaries, IAM, understanding the problem of a session. You can have triple factor authentication. Still the session, you bypass all three. So that is critical. Invest in a ZTA solution and design and actually not having security in the browser make no sense. So you need to think about that too. Split VPN, all connectivity that is splitted is another big problem. And having a plugin into your laptop that always keep VPN on, you need to pay attention that you actually verify where it's going. Because, for example, you are having an employee that is traveling. Where does he connect? Where he belongs as employment or where he is physically at that time? All these considerations, including all attack surface and bypass and manipulation, like the one that I mentioned here, need to be seen and need to be need to be designed as well. Because if you have a residual risk, you need to be sure to have on the other side of the incident response the visibility onto that. And DNS is a pain, but the HCP is even a big one, really big. If you have some malware that get access to loopback interface, it's a pain. And so you should also consider that most of this solution think and protect the asset when it's online. What is happening if something happen offline and just connect? That is a race time condition, and race time condition should be part of your design too. So I tried to just give you example on how many flow you can find in whatever solution they present you. Don't consider a ZTA as not trusting nobody, because you actually do in any case. And you need to understand who you are actually trusting and how you can control it. I hope it was an interesting one. I do suspect you not find nowhere this kind of conversation, because I didn't make it to see even one book talking about. And marketing is hammering, 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 hammering. So use your own brain, okay? Subscribe and check it out all other lesson if you haven't done it so far. Remember that you have the full syllabus in SlideShare, and so you can see what is next. Next one will be a really interesting one, because I'm talking about common architecture pattern errors. And so stay tuned. I hope to see you soon, and thanks a lot for watching. Have a good day. Cheers.